Hello, and welcome to the Gallery of Graph. And now, here's your host, Will.
Okay guys, and welcome to today's video. Today we're going to be looking at cubics, and cubics come in two main forms. We've got our point of inflection form, which is similar to like turning form in a quadratic, which is going to be y equals a bracket x minus h bracket all cubed plus k. Okay. We then also have this other form, which we call factorized form, and we'll get into that later in the video. But first, let's look at some point of inflection format questions. Okay, so now we are over in Desmos, and we can see that we have our beautiful y equals x cubed graph here.
Hey God in heaven, it's so beautiful. It's so beautiful.
No words. No words.
This is the basic form that we get a point of inflection format. So if we take a dilation factor, and that dilation factor is greater than 1, what we're going to see is we're going to see a dilation towards the y-axis there. So what does this mean? Well, if we take, let's zoom out a bit. If we take 2 cubed, 2 cubed is going to be 8. Great. But then if we take that 2, cube it, and double it, in the case of this question, we can now see that we have x equals 2, y equals 16 there. So, of course, just doubles it, stretches the graph out, and makes everything move closer towards that y-axis there. Of course, if we have a number less than 1 as our dilation factor, well, unsurprisingly, it goes further away. So now when x equals 2, y is going to be half of 8, which is 4. So that is just it's going to compress the graph, make it move further away from the y-axis. The other thing, of course, that we can look at is a reflection. And when you have a negative x value, you're going to get a graph that looks like, so it's going down left to right as opposed to up left to right. So that's a sad cubic, if you will.
Why are you always in such a bad mood?
I have a nail in my anus.
Oh.
If you have a positive h value, it moves things to the left.
To the left, to the left.
A negative horizontal translation factor, it moves everything to the right, or the positive direction. And then, lucky last but not least, we have our vertical translation factor, which is k. Yeah? And for k, what we have is we have y equals x cubed plus 1 here, and then y equals x cubed minus 1. And so when there is a positive translation factor for k, we go up by whatever that value is, in this case 1. And then when k is negative, well, the point of inflection is going to decrease. So we can see that point of inflection there is it's at 0, 0. Then we go to 0, 1, and we also have 0, negative 1 in our translation factor, negative 1. And so that is the basics. Let's jump into sketching one of these.
Oh, I won't be getting up soon.
Tutoring. Tutoring! Will's Tutoring, where you can get a free trial with 33 cancellations for temper sickness and family emergencies.
Okay, so looking at our example question here for graphing a point of inflection form cubic, what we have is we have y equals x plus 2 all cubed minus 5. And so the first thing we need to do is look at our transformations. We seem to have this h value of plus 2, so that means that we are going 2 to the left, right, the negative direction, and then we're also going to go 5 down here.
Get down. Get down.
Get down! Get down! Get down!
There's no reflections or dilations, which is great, so we can just move on to the next thing. Now, the first thing we need, of course, for a point of inflection cubic is the point of inflection, POI for short. And that is simply just going to be HK. So in this case, we've got 2 to the left, negative 2, and we've also got 5 down, so that would be negative 5. And so our graph is going to start like that. Now, it is still positive. It is still a positive cubic. It's still going up left to right because there's no reflection or negative value outside of those brackets there. So we can go ahead and use that information. Now, just real quick, if we just sketch this out for 2 seconds, -2, -5, that's going to be somewhere in the third quadrant here, and it's going to go up like so. we are probably going to have an x-intercept and a y-intercept in there somewhere. So let's go ahead and solve for those. So x-int, what does y equal at the x-intercept every single time? Is 0, of course. And so 0 is going to be equal to x plus 2 all cubed minus 5. And using our reverse BODMAS skills, first thing we're going to do is we are going to get rid of this minus 5 by adding 5 to both sides. And so what does that mean? We're going to get 5 equals x plus 2 all cubed. Well, next thing we've got to do is get rid of that cubed. How do we get rid of a cubed? We do a cubed root to both sides. And what we get is we get the cube root of 5. And then we get x plus 2 there. We can then subtract 2 to get x by itself. And we are going to get x equals the cube root of 5 minus 2. And just on the calculator, just to get a ballpark of where that is, the cube root of 5 minus 2 is going to be negative 0.29 there. So a pretty small number there. The other thing, of course, we need to do is look for the y-intercept. So y-int, what does x equal to the y-intercept every single time, guys? It's going to be 0, of course. And so we can now say that y is going to be equal to 0 plus 2 cubed minus 5. And y is therefore going to be equal to 2 cubed minus 5. 2 cubed is going to be 2 times 2 times 2, which is 4 times 2, which is 8. So then we're going to go y equals 8 minus 5, which is going to be equal to 8 minus 5 is 3. Or in coordinate form, 0, 3. So the point of inflection is at negative 2, negative 5 there. And then we're going to put our intercepts in. So we have cube root of 5 minus 2, which we think is at the negative 0.3, essentially. 0.29 rounds up to 3. So that's going to be right about here. And then our other one is our y-intercept. And then our y-intercept is at 3. So we're going to go 1, 2, 3. And our graph is going to look something like this. Correct. And so let's just fix up that x-intercept there. So let's just label our points now. We have negative 2, negative 5. We also have our cube root of 5 minus 2, comma 0. And then finally we have 0, 3 there. And then that is how we draw a cubic from point of inflection form. And now we're going to look at doing a cubic from factorized form.
Do you sell math?
We sell forbidden objects from places men fear to tread. We also sell frozen yogurt, which I call Frogut.
Well, I need something for my son or daughter's math grade.
Perhaps this will please the gentleman. Take this object, but beware, it carries a terrible curse.
Ooh, that's bad.
But it comes with a free trial session.
That's good.
It also has calculator tutorials for both the Casio ClassPad and TI Inspire.
That's good.
Will has 11 years of tutoring experience.
That's good.
You get 3 free cancellations per term for sicknesses and family emergencies.
That's good.
It comes with a free Frogut.
That's good.
You get your choice of topping.
That's good.
The toppings contain potassium benzoate. That's bad.
Can I go now?
Okay, and so looking at factorized form here, guys, what we have is we have 3 different variants of essentially the same thing. Of course, with a cubic, you could have up to 3 different factors for x, and so therefore we can have our first type here, which is going to be x minus alpha, x minus beta, x minus gamma. Of course, these could be any numbers. I've just used the Greek letters as variables here. And so with this, of course, when we have 3 different factors, what does this mean in terms of a graph? Well, what it means is that we have 3 different intercepts. Now, in the case of this particular graph, I've gone ahead and graphed x plus 1, x minus 1, x plus 2. And we can see that our intercepts are the null factor solutions to that. So x plus 1, well, that's going to give us our negative 1 value here. X minus 1, that's going to give us a positive 1. And x plus 2, that would give us negative 2, because we are solving all of these as if x plus 2 equals 0, x minus 1 equals 0, vice versa. So we get 3 different intercepts when we have this format. The next format we have here, guys, is going to be y equals x minus alpha squared times by x minus beta. And this is a situation where essentially we have a squared factor and a non-squared factor giving us our cubic. And, well, in this case, switching over to Desmos, and in this case, what we have is we have we would have this sort of situation here. So in this one, I've gone ahead and graphed y equals x plus 1 times by x minus 1 squared. Now, just like in the other one, we can see that x minus 1 is what we're going to get when we solve x plus 1 equals 0. But the interesting thing is now that we have this squared here, our x minus 1 becomes a turning point intercept. So the graph comes all the way down, gives that x-axis a little smoochy there, just a little bit of a... And then it goes back up because it just touches it with a little turning point and then comes back. So we can zoom all the way in here and it's always going to be just approaching that point of 1 there. And so that is the ins and outs of how we do a squared cubic graph, if that makes sense. So one of the factors is squared there. The final type of graph that we're going to get here, guys, is going to be a y equals x minus alpha or cubed graph. And that is just a point of inflection graph like we had before. So just to show you again, though, if we go over to Desmos here, you can see that we just get our point of inflection at the intercept like we would expect with a x minus any h value graph. So that's nothing special about that one. Anyway, now let's jump in and look at how we can sketch some of these questions. Okay, and looking at our first example here, we have sketched the graph of y equals x minus 1, x plus 1, and x plus 2. Okay, well, we're not given any transformations here, of course, because we're in factorized form and not point of inflection form. So, hey guys, just going to interrupt the video for a second, but if you are enjoying it, then please consider supporting the channel. Old Willie's maths and memes don't put themselves together, I can tell you that. So if you would want to support my work, then please consider buying me a coffee or donating on PayPal. Additionally, I do have a Patreon where I'm going to be uploading chapter-specific solutions to the problems out of a popular textbook series that rhymes with Lanebridge, if you're in Australia. And so if you want to get that, sign up for the Patreon. And finally, if you would like more bang for your buck, then why not hire The Real Deal by contacting me on Facebook or Instagram or X or YouTube or all of the social medias and organizing a free trial session from Will's Tutoring, where you can also get 3 free cancellations per term for sickness and family emergencies. Anyway, like and subscribe to the video. That's the end of the plug. Bye! What we can do is we can just go ahead and look for our x and y intercepts. So let's start off with the x int. What does y equal the x-intercept every single time? It is, of course, 0. So we can say 0 equals x minus 1, x plus 1, x plus 2. And applying our null factor law, well, what we need to do, of course, is to make something equal 0 is times it by 0. And so what does that mean? It means that we need to make these brackets equal 0 in some capacity. So to make the first bracket 0, x would have to be 1. To make the second bracket 0, x would have to be -1. And to make the third bracket 0, x would have to be -2. So our x-intercepts are therefore going to be 1, 0. Then we also have -1, 0, and then finally -2. Great. And so will be useful for graphing our graph. The other thing, of course, we have to do is we have to find our y-intercept, right? And at the y-intercept, what does x equal, everybody? Say it with me. It's 0. And so therefore, what are we going to do? We are going to say that y equals 0 minus 1, bracket 0 plus 1, bracket 0 plus 2. And then, of course, that's going to just give us -1 times by 1 times by 2 there. -1 times 1 is -1 times by 2 is going to be -2, or in coordinate form, 0, -2. And so that is everything we need to graph our graphy McGraph. So let's chuck down some axes here, y, and we've got x, and let's go ahead and mark out our intercepts. So we have 1 at 1, we have 1 at -1, and 1 at -2. We also have our y-intercept at y equals -2, and so then we can go ahead and graph our graph. Now, of course, a cubic can look like this when we have it in point of inflection format, right? But also cubics can get pretty wild. They can have basically a peak and a trough within inside of them. So what we get here is we get this sort of situation like so. And now we can go ahead and mark in our points, which are going to be -2, 0. We've also got -1, 0. We also have 0, -2, and then finally we have 1, 0 there. And that is going to be everything you need to graph that one.
Like and subscribe.
What looks like somebody's Haagen-Dazs ice cream. Oh, I should write this down.
More coming. I'm looking for something in an after-dinner burrito.
You'll have it in 45 seconds, sir. To pass the time, please enjoy this novelty pen.
4, 3, 2, 1. Lift off!
Look at this mess. Where is that elderly old man? Old man! Old man! Ah!
Hey, look! A freezer man!
Wait a minute. There is a note.
I have frozen myself so I may live to see the wonders of the future. Thaw me out when robot wives are cheap and effective. P.S. Please alter my pants as fashion dictates.
Son, I represent a group of oil tycoons who make foolish purchases. Now we need your Iceman.
Oh no, I could never sell him. He is like a frozen father to me.
How much for just the head?
By gum, it worked. I've awakened in the future.
Will's Tutoring, where you can get a free trial session and 3 free cancellations per term for sickness and family emergencies.
What a time to be alive.
Looking at our second example here for factorized form cubics, well, we have a situation where we've got a squared factor. And in this case, we are looking at sketching y equals x minus 1, x minus 2 all squared. And of course, there's no transformations or anything to take account of because it's in factorized form. And so what we need to do, of course, is we need to go ahead, find out x-intercepts. And what does y equal at the x-intercept? Of course, it is 0 every single time. And so that means that 0 is going to be equal to x minus 1 bracket x minus 2 all squared. And of course, using our null factor law, we need to make both of these brackets equal to 0. And so therefore, x is going to be 1 or 2. And our coordinates will be 1, 0 or 2, 0. And when we have a squared, one thing that I like to do is put a little asterisk here just to signify that that is the squared intercept. Yeah. We also need to find our y-intercept. So y-int, what does x equal at the y-intercept, everybody? It's, of course, 0. So y is going to be equal to 0 minus 1, 0 minus 2 squared. And, of course, that means that we're going to get 0 minus 1 is -1. 0 minus 2 is -2, but this is squared. Then we get y equals -1 times by, well, -2 squared is -2 times -2, which is +4. And y is going to equal -4, or in coordinate form, 0, -4. And now that we have all of that, we can, of course, go and graph this bad boy. So let's go and slap some axes down. And we're then going to go y and x here. We, of course, need to put in our intercepts at 1 and 2 for x. So there and there. And then the next step is to put in our y-intercept at -4 all the way down here. Okay. And so now drawing our graph, guys, we're going to go y-intercept, x-intercept, coming around to the turning point intercept, give it a little kiss, and then back out like so. And of course, this is a artist's rendition of a graph and not to be taken literally like a computer simulation would be. But if you drew something like this and had the correct intercepts, people would probably give you a pass. So last thing, of course, is to label our intercepts 0, -4 there. We also have 1, 0, and then 2, 0 for our 2 intercepts there. And then that is how you graph a cubic from turning point form. I hope this video has been helpful to you guys. And if you did find it helpful, please consider giving me a like and a subscribe and a follow on all of the social medias. I actually run a personal tutoring service. So if you're interested in personal tutoring, please reach out to me on Facebook, Instagram, or the Twits. I also have a YouTube channel, and I also have a Patreon. So if you're an Australian student and you learn from a textbook which is published by a publisher that rhymes with Lanebridge, wink wink, I run a Patreon where I have answers to the questions out of that textbook. So yeah, consider checking that out too. Well, that's it for the video. So thanks for watching.
Bye.